Hi folks, welcome back. I hope you're all doing well. When you look at the process of writing code in a large modern software company, it is done with the help of a giant machine. And this giant machine is made up of a large patchwork of tools that help the programmer at every stage of the cycle of writing software. Things like linters, automatic build, test, and deployment tools, IDEs, autocomplete, code search over your repository, and so on. And over the last few years, we've seen a new area of research emerge which tries to apply ML techniques to help the task of programming as well as fixing bugs in existing code. This paper I'm looking at today is an industry experience report from authors at Facebook who implemented 3 tools that work in the area of both suggesting new code as programmers are trying to write code, as well as fixing bugs automatically. The crucial thing that enables a lot of these techniques is the availability of huge data sets. Not only is the code repository itself a huge data set, but there's also a large amount of metadata. Usually that metadata is the commit history, as well as the linkage of that commit history to the issue tracker, which can tell you what sorts of commits were used to fix what sorts of bugs. So let's start by looking at the 3 problems that the authors tried to solve and then look at how exactly they did it. The first problem they want to solve is searching over code using natural language. When you have a large and complex set of APIs to use in your programs, you often don't know the exact names of the classes or methods that you want to look for. And in that case, it really helps to start your search with just some high-level rough keywords. The second problem they look at is to recommend code, which is an extension of this first problem, but instead of using natural language as an input, you provide a very short code snippet as an input. And the goal of the algorithm is to provide a small list of idiomatic related code snippets that show common usages related to the input code snippet. And the final problem is to automatically fix common bugs. By looking at the commit history and the linkage of which commits were used to fix which bugs, one could build a model of the kinds of code patterns that are used to fix common bugs. To start with, the authors are looking at common static analysis warnings because that tends to be a very commonly found set of warnings during code review. And they also usually tend to have pretty simple and easy to understand fixes. Okay, so let's look briefly at the implementation of all of these. If you look at the first one, which is searching over code with natural language, they call their tool NCS or Neural Code Search. And the central idea of NCS is to use embeddings, which is a common machine learning techniques where you extract a representation of the thing you're modeling and embed it into a vector space. The key idea here is to build word embeddings of words found in your source code, and to do it in such a way that words that commonly appear with each other in similar contexts are close to each other in this vector space. The example they give here is if you look at the word button, you'd expect that to be close to the vectors for words like click or pop-up or dismissible. And then the way the natural language search works is that you tokenize your input, your query, and try to find the embeddings in the vector space that are closest to your query. The way they evaluated this tool was to look at a bunch of Stack Overflow questions and see whether NCS could find the correct code answer to those questions by training it on a bunch of GitHub repositories. And what they found was about a 1/3 hit rate. So out of 287 questions, NCS was able to get the correct answer in its top 10 results 98 times. And this tool got integrated into the main code search tools at Facebook, and so it must be getting quite a bit of usage. So moving on to the second problem, which was recommending code but starting not with a natural language query but with a short snippet of code. They built a system called Aroma in order to do this, and I've actually done a complete video on the Aroma paper. I'll link to it in the description, but it also uses vector representations as a key implementation technique. In terms of the experience at Facebook, the authors mentioned that they integrated Aroma into the IDE itself, kind of like a very advanced version of autocomplete. However, they got some mixed feedback because programmers were not sure about how exactly they should be interpreting these suggestions. And so the authors have taken that feedback and rolled it into a new tool for presenting code examples. And finally, we come to automatic program repair or automatic bug fixing. And the authors built a tool called GetAFix, which learns these bug fixing patterns and suggests fixes to common bugs. Now, I've done a full video on GetAFix as well, which I'll link to in the description. But the basic idea is to look at the abstract syntax tree of the code where the fix was made, and then to see a diff of that AST before and after the fix to build a model of what the fix exactly was. They use this for null pointer error warnings, which are very common. And in 42% of the cases, the programmer accepted the tool's suggestion. And in a further 9% of the cases, the engineers rejected the suggestion but ended up writing code which was semantically identical to the suggestion. So maybe the same code but with some formatting or naming changes. The authors end with some thoughts on where to take this line of work next, and they situate it within the common life cycle of software development. So if you look at the entire process of writing code in your editor to building it to then doing continuous integration and build and release to production of this code, the tools that they talk about in this paper look mostly at the code editing phase of the programmer's workflow. And what the authors are pointing out is that there is a lot of room for building similar tools in all the other phases of the code writing workflow or the code deployment workflow. For example, if you look at code review, you could build models that assess the risk of a code change. So that was a quick look at a real-world industry experience report for deploying tools that automatically fix bugs and that help programmers find relevant code snippets as they're writing code. I hope you enjoyed that, and I will see you next time. Thank you very much.